let's look at exact trigonometric values. We start with an equilateral triangle where each of the side lengths are of 2 units, and within the equilateral triangle, each of the interior angles is equal to 60 degrees. If we split this triangle into half down the middle, we would end up with 2 right-angled triangles. If we split this, we would get one of the triangles that are formed within this equilateral triangle. So we have a right-angled triangle. This top angle here, 60 degrees, has been cut into half, and so we end up with 30 degrees. We have that the bottom side length, which was of 2 units, is also split into half, and so we have a side length of 1 unit at the bottom here. We're going to work out the perpendicular height of this right-angled triangle, and we can do that using Pythagoras' theorem. Have that the perpendicular height is equal to the square root of 3. So if we start off with 30 degrees, we're going to write the opposite, adjacent and hypotenuse within this triangle in relation to 30 degrees. We have the opposite side, which is 1 here, we'll label that as O. We have the hypotenuse, which is the side opposite the right angle, so that's the 2 here, we'll label that as H. And then the side that's remaining is the adjacent side, which we'll label as A. Sine of 30 degrees would equal to the opposite side over the hypotenuse, in this case 1 divided by 2. And so sine 30 as an exact value is equal to a half. Cos 30 degrees is equal to the adjacent side over the hypotenuse. And so in this case, that's equal to the square root of 3 divided by 2. Tan 30 degrees is equal to the opposite side over the adjacent side. In this case, that's equal to 1 over the square root of 3. If we rationalize the denominator, in other words, multiply the numerator and denominator by square root of 3, we end up with the square root of 3 over 3. So we have the opposite side in relation to 60 degrees is square root of 3, so we'll label that as O. The hypotenuse is the side that's always opposite the right angle, so in this case that's 2, we'll label that as H. And the adjacent side is the side that's closest to the angle that isn't the hypotenuse, and so in this case that's the 1, we'll label that as A. Sine 60 degrees is equal to the opposite side over the hypotenuse, in this case the square root of 3 over 2. Cos 60 degrees is equal to the adjacent side over the hypotenuse, in this case 1 over 2. And finally, tan 60 degrees is equal to the opposite side over the adjacent side, in this case the square root of 3 divided by 1, which is the same as the square root of 3. We have a right-angled isosceles triangle with side lengths 1 and 1 and a hypotenuse of root 2. Let's first label each of the side lengths in relation to the 45 degrees that we have here. We have sine of 45 degrees is equal to the opposite side, 1 over the hypotenuse, root 2. So 1 over root 2, which if we rationalize, in other words multiply the numerator and the denominator by root 2, we end up with root 2 over 2. Cos 45 degrees is equal to the adjacent side over the hypotenuse. So in this case 1 over root 2. And again, if we rationalize this, we end up with root 2 over 2. And then tan 45 degrees is equal to the opposite side over the adjacent. So in this case 1 over 1, which is the same as 1. Have the opposite side is equal to root 2. We also have that the hypotenuse is also equal to root 2, since the side opposite the right angle is the hypotenuse. And the adjacent side is where we have a bit of an issue, because we could either have the 1 here or we could have the 1 here. And so since we've got 2 different options for the adjacent side, we use that the adjacent equals to 0. So sine of 90 degrees is equal to the opposite side over the hypotenuse. In this case, the opposite is root 2 over the hypotenuse, which is also root 2. Root 2 over root 2, anything divided by itself, equals to 1. Now cos 90 degrees is equal to the adjacent side over the hypotenuse. So in this case, we said the adjacent side is equal to 0 over the hypotenuse, which is equal to root 2. 0 divided by root 2 is equal to 0. To work out tan of 90 degrees, we have the opposite side over the adjacent. And so the opposite side is root 2, the adjacent side is 0. And in this case, we've got a number divided by 0. Any number divided by 0 is always undefined. And so we say that tan of 90 degrees is undefined. And we've worked out the values of sine, cos, and tan for 45 degrees and 90 degrees. So let's look at how we can work out sine, cos, and tan of 0 degrees. So we've got several diagrams here, and each of these diagrams represents a right angled triangle where each of the sides have been labeled as the opposite, adjacent, and hypotenuse in relation to an angle called theta in the bottom left corner. What we're trying to show is what happens to the opposite, adjacent, and hypotenuse as the value of theta gets closer and closer and closer and closer to 0. If we look at the opposite side, we start off with this opposite side being fairly long, and in the next triangle, as theta has gotten smaller, the opposite side has also decreased in length. And again, in the next triangle, as theta has gotten even smaller, the opposite side has also got smaller. As theta has got closer and closer to 0, we see the opposite side gets closer and closer to 0 until eventually it equals to 0. We also look at the adjacent and the hypotenuse. We see that as theta gets closer and closer to 0, the hypotenuse and the adjacent get closer and closer and closer to each other in length until eventually the adjacent is equal to the hypotenuse. So since the adjacent and the hypotenuse are equal to each other, we're going to call them some value, let's say x. Then we have that sine of 0 degrees is equal to the opposite side over the hypotenuse. In this case, the opposite side is equal to 0 and the hypotenuse is equal to x. And so 0 divided by x, or any value, is equal to 0. Cos of 0 degrees is equal to the adjacent side over the hypotenuse. So the adjacent side we said is equal to x, that's just any value. The hypotenuse would also have to equal to that value when theta equals to 0. And so we have that the adjacent side, x, over the hypotenuse, x, simplifies to 1. So cos of 0 degrees equals to 1. And finally, to work out tan of 0 degrees, we have the opposite side over the adjacent. And the opposite side is equal to 0. The adjacent side is equal to x, that's some value. And so 0 divided by any value is equal to 0.